Hello and welcome to G Fun Facts Online, the show that uncovers the surprising science behind our everyday lives. Today, we're looking at something you've probably used already today without a second thought. The simple bottle cap. That little piece of plastic or metal that gives a satisfying crack when you twist it open, promising a fresh, safe beverage inside. But what if I told you that with every twist, you're potentially releasing a shower of microscopic plastic particles into your drink? And that as that bottle sits on a shelf, a cocktail of industrial chemicals can be silently seeping from that cap into the liquid you're about to consume. It sounds like science fiction, but this is the very real science of microplastics and chemical leaching. It's a hidden world of contamination, with profound implications for our health and the environment. The story of the bottle cap is a microcosm of our broader relationship with plastics, a tale of incredible utility, but also a cautionary tale of unintended consequences. So grab your favorite reusable mug, and let's dive into the unseen world sealed by a bottle cap. To truly understand the problem, we first need to dissect the cap itself. These aren't just simple discs of plastic. They are often complex assemblies, marvels of engineering designed for high-speed bottling lines and airtight seals. The vast majority of plastic caps you see on water bottles, milk jugs, and sodas are made from two main types of polymers: high-density polyethylene, or HDPE, and polypropylene, or PP. Think of HDPE as the robust, reliable workhorse. It's known for its strength and resistance to chemicals and moisture. Its molecular structure is made of long, tightly packed chains of ethylene, giving it that characteristic density. It's also forgiving, which means it can handle the intense mechanical stress of a modern bottling factory. Polypropylene, or PP, is the other industry giant. It's often used for caps on carbonated drinks because it's rigid, resistant to fatigue, which is great for those hinged caps you sometimes see, and it can handle higher temperatures. While those two dominate, other plastics like PIT or polystyrene are sometimes used, but it's really the reign of HDPE and PP. But what about the metal caps, the kind you find on glass bottles of beer or classic sodas? Those crown-style caps are typically steel or aluminum, but they are not purely metallic. To get that perfect airtight seal and to stop your drink from tasting like metal, they have a secret weapon on the underside, a plastic liner. And this is where things get really concerning. A very common material used for these liners is polyvinyl chloride, or PVC. You may have heard of PVC, sometimes called the poison plastic. By its nature, PVC is hard and rigid. To make it soft and pliable enough to form a seal, manufacturers have to add huge amounts of chemical additives called plasticizers. These plasticizers can make up a staggering 40% of the liner's weight. And here's the critical part: they aren't chemically bonded to the PVC. They are more like uninvited guests, mixed in but not truly part of the structure, meaning they can easily leave and migrate into the environment or into your beverage. So the cap itself is just the beginning. The real story is in the chemical cocktail mixed in to give plastics their desired properties. These additives, just like the plasticizers in PVC, are often not locked into the polymer and can leach out over time. Let's talk more about those plasticizers. For years, the most widely used plasticizers in PVC were a class of chemicals called phthalates. A 2021 report by the Ecology Center titled "Capped with Toxics" delivered a bombshell finding. It discovered that more than one-third of the beverage brands they tested were using bottle cap liners containing these phthalates. Specific chemicals like DEHP and DINP were identified. Studies have confirmed that these chemicals can migrate from the cap liners directly into food and drinks. They can even leave a residue on the rim of the bottle, which you then consume as you take a sip. Due to the growing health concerns around phthalates, many manufacturers have started switching to alternatives, like chemicals named ATBC or DOTP. While these are generally considered safer, for some of them, the jury is still out on their long-term health effects. There are still significant data gaps. But the chemical cocktail doesn't stop there. A whole range of other additives are in the mix. Stabilizers are added to prevent plastics from degrading when exposed to heat, light, or oxygen during manufacturing and storage. These can be based on metals like calcium and zinc, but historically, some stabilizers were based on toxic heavy metals like lead and cadmium. While largely phased out in many places, they can still sometimes appear in recycled materials. Then you have colorants, the pigments and dyes that give caps their vibrant brand-specific colors. And the list goes on. Lubricants, slip agents, anti-static chemicals, even flame retardants can be present, all designed to fine-tune the plastic's properties. So how exactly do these microscopic particles and invisible chemicals escape their plastic prison and end up in our drinks? The process is a combination of physical force and slow chemical decay. One of the most direct and shocking sources of contamination is the simple act of opening and closing the bottle. A peer-reviewed study in the Journal of Water and Health found that the friction created by twisting a screw cap generates a significant number of microplastics. How significant? The study estimated that each single twist can produce around 500 microplastic particles. Let that sink in. Every time you open that bottle of water, you could be creating a tiny snowstorm of plastic inside. Another study confirmed this, subjecting bottles to 100 open and close cycles. They found a considerable increase in microplastics, especially on the cap's surface, concluding that the abrasion between the cap and the bottleneck is the dominant source. The capping process at the factory itself, with all its high-speed stress and friction, is another likely point of origin for these particles. Beyond physical force, there's the slow, relentless process of chemical degradation. Over time, the plastic itself can start to break down, releasing both microplastics and its chemical additives. And this process is supercharged by two common environmental factors: heat and light. Heat is a major catalyst. Think about leaving a water bottle in a hot car. Higher temperatures increase the kinetic energy of the molecules, causing polymer chains to break and allowing additives to migrate much more easily. Studies have shown that storing water in PET bottles at high temperatures dramatically increases the leaching of antimony, a chemical catalyst used to make the plastic. At temperatures of 50 degrees Celsius or 122 Fahrenheit, the release can be very rapid. This is why you should never leave bottled drinks in direct sunlight or a hot vehicle. The other major factor is ultraviolet radiation from sunlight. UV rays are powerful enough to break the chemical bonds in plastic polymers, a process called photooxidation. This makes the plastic brittle, creating a chalky surface layer that easily sheds particles and chemicals. Polypropylene and polyethylene, the two main plastics in our caps, are particularly susceptible to this kind of UV damage. So we have these tiny plastic fragments and a cocktail of chemicals leaching into our drinks. What's the big deal? The potential health effects are the focus of intense scientific research, and while there's still a lot to learn, the findings so far are deeply concerning. Let's start with the microplastics themselves. Once ingested, these particles can cause physical harm. Their sharp, irregular shapes could cause inflammation or damage to our digestive system. Even more worrying are the smallest particles, called nanoplastics. There is growing evidence that they are small enough to pass through the intestinal wall and enter our bloodstream, potentially traveling to organs throughout the body. In recent years, researchers have found microplastics in human lungs, in breast milk, and even in placental tissue, proving their widespread infiltration into our bodies. On top of that, microplastics can act like tiny toxic sponges, absorbing other chemical pollutants from the environment and delivering them directly into our systems. Then there are the leached chemicals themselves. Many of these additives, particularly phthalates and another well-known chemical, BPA, are known endocrine-disrupting chemicals or EDCs. Think of EDCs as identity thieves for your body's hormones. They interfere with your endocrine system, which is responsible for regulating everything from growth and development to reproduction and metabolism. This interference can lead to a host of serious health problems, including reproductive disorders, developmental issues in children, and an increased risk of certain cancers. The environmental consequences are just as grim. Bottle caps are consistently one of the top items found during beach cleanups. They are a massive source of plastic pollution. In the environment, they break down into smaller and smaller microplastic particles, contaminating our oceans, rivers, and soil. These particles are ingested by everything from microscopic zooplankton to massive whales, causing them physical harm and introducing toxic chemicals all the way up the food chain. So what is being done about this? The regulatory landscape is, frankly, a complex and inconsistent patchwork. Agencies like the FDA in the United States and the EFSA in Europe do set limits on the migration of some known harmful chemicals. However, these regulations often focus on a small list of bad actors, while thousands of other chemicals used in plastics have not been fully assessed for safety. Furthermore, there are currently no specific regulations that address the issue of microplastic leaching from our food packaging. But it's not all doom and gloom. Some companies are listening. The Capped with Toxics report did note that many market-leading brands have already switched to phthalate-free, PVC-free bottle cap liners, proving that safer alternatives exist and are viable. However, the same report found that many other brands, especially smaller ones, continue to use the older, more hazardous materials. This highlights the need for stronger regulations to protect all consumers. Addressing this challenge requires a multi-pronged attack. The most promising path is the development of safer materials. This means moving away from PVC liners entirely and accelerating research into new, more stable polymer formulations that are simply less prone to leaching. Changes in design could also help. Engineers could develop low-friction cap and bottleneck systems to reduce the generation of particles when you twist them open. The new tethered caps, designed to reduce litter, might also have the side benefit of reducing how many times a cap is twisted on and off. But perhaps the greatest power lies with us, the consumers. The single most effective way to reduce your exposure is to reduce your consumption of bottled beverages. Opting for filtered tap water in a reusable container made of glass or stainless steel is a game changer. When you do buy bottled drinks, store them in a cool, dark place. And please, avoid reusing single-use plastic bottles. They are not designed for it, and repeated use can increase the breakdown of the plastic and the risk of leaching. The science of the bottle cap is a stark reminder that our most mundane objects can have complex and far-reaching consequences. What starts as industrial chemistry ends up in our kitchens, our bodies, and our oceans. The constant, low-level exposure to a stream of microscopic plastics and potentially harmful chemicals is a public health challenge we are only just beginning to grasp. The evidence is clear. The simple friction of a twist and the warmth of a sunny day can release a hidden flood of contaminants. The path forward demands a concerted effort. Industries must innovate for safety, regulators must catch up with the science, and we, as consumers, must make informed choices to protect ourselves and drive change in the marketplace. The journey from the factory to our tables should not be a pathway for pollution. By shedding light on the hidden science of the bottle cap, we can begin to demand and create a future where our food and beverages are as clean and safe as they are convenient. Thanks for tuning in to Fun Facts Online. We'll see you next time.